Hey, Algebra 2, welcome to your mid-topic for review. Haven't taken a video of one of these in a while. We're going to do it now. This is done for your reviewing pleasure. Okay, start the video. All right, so the first thing we're going to talk about is if we have direct variation, inverse variation, or neither. So what we're going to do is check. Let's see. Remember, so for direct variation, direct or inverse. For direct variation, we're going to check that y equals k. Also check that k equals y over x. So it's the same formula, just manipulated in different ways. If we're going to check for indirect variation, inverse variation, we're going to look for y equals k over x or k equals x over y. All right. So let's check this thing out. So is it true? So first of all, I can see, is there a common difference happening here, right? If so, then that's that value k, right? So we can also check if our constant difference is y over x. So let's actually look at this. So from 25 to negative 60, that is going to be negative 60 plus 25 or 85. But now we're going back up here. So I'm going to suspect this is not have a direct variation because now we've got 95. That's weird, right? Okay, so let's check number one for direct variation. I can see 25. We're going to go y over x. So I'm going to go ahead. Sorry, I'm using this one. So we don't know what k is. And we know x is 1. So we have that k is 5. If you divide this by 5. So is it the case then? So now we're going to go back to this one. Is it the case that k is y over x? So is it the case that 5 should actually be k is not 5? All right. Is it true that 5 is equal to y over x? It would be true. All right. I want to see, does this value of k work? And it shouldn't at some point. Yeah, so this is the issue I'm running up against. It says that k, our constant of variation, is 5. But, oh, it does look like it is 5. What am I thinking? Oh, I'm a little slow this morning. Yeah, it does work, right? If I multiply this by 5, I get 25. Negative 12 times 5 is negative 60, right? So this constant of variation is legit, right? K is definitely 5. So then, this is a direct variation. I don't know why it was freaking me out that this difference was different, but we have a constant of 5. It works. We can actually write the equation. This is going to be y equals 5x, which means that it is direct variation because it's in that form. Yeah, sorry, it was looking a little weird to me, but it works. If we look at this right, so this matches. This is a form of direct variation. We've got the same thing. The constant is 5, right? If I do 5 times 5, I get 25. If I do 5 times 12, I get negative 60, and so on. So that constant of variation is 5. It's working, and it's direct variation. Sorry, it took me a little minute to get there. Let's check and see if this one has direct variation. So I do see that there is a constant increment. And let's see if y equals k. X, we're going to check for direct variation first. 6 equals. Let's figure out what k is, and if k actually does work as a constant for multiplying. So 6, 24. So I'll divide both sides by 24. And we get that k is 1/4. So is it true that if I multiply 24 times 1/4, I get 6? Well, yeah. But what happens when I multiply 49 times 1/4? 49 fourths, or 11 point. Wait, what did I say? 1/9? Oh, I should be in there 2 times there, so 9. That 12. Yeah, about 12.1. About 12.25 something. Sorry, my bad. So no, this is not direct variation, right? This constant of k is not working for this, right? Because this does not. That's what we need, right? So it does not pass the test for direct variation. Let's try inverse variation. Let's figure out what k is, y. So now we're using the inverse variation. Let's get it right here. We're going to look at y equals k over x. So we've got 4 is going to be equal to, we don't know what k is. My bad. This should be 6, 4 times by 24. Six times 24 is 80. Sorry, my bad. 120 plus 24, or 144. Is it the case that, so does this fulfill, let's say k is equal to x times y, our x value, let's try another one, let's try it. So we know that 24 times 6 works. Let's see if that's what I'm going to do. So we're looking to see, I am checking this out. Let's see if this works. Is 144, 49 times 7. Keep doing shape. So we get 3 quarters. So this one fails direct variation, fails the test for inverse variation, so it's neither, and there is no constant k for this. Oh yeah, that makes perfect sense. All right, perfect. Let's move on. Next. All right, so each one of these involve inverse variation. So we're going to be sticking with the equation y equals k over x. All right, so our first plan is to find out what k is. And then we can write an equation for this inverse variation. So if we're given y and we're given x first, so we're going to use these two values to figure out what k is. 10 is equal to k over 6. Okay. So we multiply both sides by 6 to get that thing out of our denominator, and we get that 60 is what k is. So now I have a new equation. I have y equals 60 over x. And now I can figure out what the value is for x equals 5, y equals 60, y equals 5, which means that y much more straightforward than the previous. Kind of explore the relationship a little bit. Let's try another one. We have inverse variation here. So y varies inversely, so that means that we have y equals k over x is going to be our starting point. We're given y and we're given x, so let's figure out what k is. So we have 6 equals k over 15. We'll multiply both sides by 15 to get that to go away, right? Those will cancel. That is 60 plus 30 or 90. That's what k is. All right, now we'll just plug that in here. So we get y equals 90 over x. That's the equation of this inverse variation. This relationship that varies inversely, one could even say. And they want to know what y is. So y is going to be 90 divided by 2, right? They want to know what y is when x is 2, which means that y is going to be 90 divided by 2 or 45. And there you have it. All right, so the next thing we're going to do is find vertical. Vertical and horizontal asymptotes. I was like, ooh, that would have been easier. Vertical asymptotes are fairly simple. They're values that x cannot be, right? Values that x cannot have. And so when we're looking for values that x can't have, right, remember, we never, ever, ever, ever divide by 0, yeah? So if there's a value of x that makes this thing 0, it cannot be. It just can't happen. We never divide by 0. There's no such thing as dividing by 0. And I could get deeply into that if you wanted to, but I think we'll just through this. How do I find out what values of x will make my denominator 0? Well, I just solve this thing for 0. So I will subtract 9 from both sides, divide both sides by 3, and I get that x is equal to -3. This guy's right here is my vertical asymptote. I feel like that's the easy one because I don't have to memorize anything, right? Fortunately for you guys, if you have your notes on this quiz, then you won't have to memorize these facts either. But in order to find our horizontal asymptotes, there are some facts that we need to recall. Up here. Now. So here they are. We got to have these facts in mind when we're looking at horizontal asymptotes, right? So we got the 3 cases. That the degree of the numerator is less than the degree of the denominator, right? That case 2 and case 3, we can write them. I don't need to read them for you. You all are good kids. So let's look and see which case this is. Which case is it? The degree is higher, right? This degree of my numerator is higher. So what does that say about my horizontal asymptote? The degree is greater. We got case 3 right here, right? No asymptotes. So that's what we'll write down. And I'll put it here in case you have it in your notes. Case 3. No asymptotes. We're talking about horizontal. This one was vertical. All right, over here. If we want to figure out what our vertical asymptote is, I gotta solve that. Easiest, best way to solve this is to factor it. So let's do it. Two numbers such that when I multiply them, I get -3, and when I add them, I get +2. I like +3 and -1, which means that my vertical asymptotes are at x equals 3 and at x equals 1. These guys are my vertical guys. And what do we have here? We have same, right? The degree of my numerator and the degree of my denominator are exactly the same, right? 2. Both are second degree polynomials in my numerator and in my denominator. What does our rule say for that? It looks like case 2. Horizontal asymptote is going to be the leading coefficient. All right, so we've got our leading coefficient, which is 2. So we're talking about leading coefficient. We're talking about this one. This is our leading coefficient. What is our leading coefficient of the problem we're working at? It looks like our leading coefficient is 1 because there's a little invisible 1. So we would say that there is a horizontal asymptote at y equals 1. Shall we do another one? Heck yeah. All right, let's look for our vertical asymptote. We're going to have to solve x squared minus 2x minus 3 equals 0. Hey, it's not going to be the same as the previous one. It's slightly different. It's a negative 2x instead of a positive 2x, which will make it factor slightly differently. Now I need to take the two numbers such that when I multiply them, I get -3, but when I add them, I get -3. I like -3 and +1. So it's going to be a slight change because now I have a vertical asymptote at x equals 3, and I have a vertical asymptote at x equals -1. So these guys are my vertical asymptotes. Let's look at horizontal asymptotes. It looks like the degree of this is now less, right? The degree of my numerator is less than the degree of my denominator. We have a rule for that. I wouldn't be surprised if it's case 1. Let's look. The degree of the numerator is less, right? So this is x to the first power, that's x to the second power. So we definitely have case 1 in this one, which means that our horizontal asymptote is in automatically y equals 0. So our horizontal is at y equals 0. Boom. All right. I like that. We did 3 of them. We got all 3 cases for you guys so you can see how that works. Let's move on to the very last problem. It's so easy too. Just a simple Desmos match a graph type problem, but we're going to do it anyways. All right, so last thing we need to do is identify the graph of function. All I'm going to do is put this in Desmos and graph it, right? So -x minus 3. I'm going to put this in parentheses when I do it. I'm going to put -x minus 3. And then I'm going to put divided by. It's going to make a fraction for me. X minus 3. And
Let's zoom out a little bit. We're going to match this. Which one? So it looks like it has an asymptote at like 1, or I don't know, maybe that's 2. Something like that. Let's find the one that matches those asymptotes. Whoops. All right. It's looking like D. All we got to do is match. Easy peasy. All right, guys. Don't forget to study. Don't forget to bring your notes. Have this stuff written down. Thanks for watching. Hope you're having a great day. And if you're not, I hope it gets better.